Let's step back 2 billion years back into Earth's evolution. A time full of life, but also mass extinction. An invisible killer was on the loose, ready to change the course of history. This was a time on Earth that had direct impact on what the world's like today. The animals that inhabit it, the food that we eat, and the air we breathe. Would you be able to survive in this new environment? And how did almost all life come to an end during this time? Time to go back 2 billion years ago. Welcome to Earth 2 billion years ago. You're landing at a time when Earth is about halfway to its current age. Now, as you make your descent towards this prehistoric Earth, you'll see blobs of land and maybe some chunks of ice separated by water. These land masses look nothing like our continents today, but that's gonna change soon. As your time machine touches down, it's a bleak and rocky landscape. There are no plants, no trees, no vegetation at all. No signs of any animals either. This was a time before complex multicellular life. The only living things on Earth were microorganisms. Yeah, it might sound a little dull, but at least there are no predators you need to worry about. I hope. Before you step out on the ground, you better put on your suit that's fitted with oxygen tanks, because while there is oxygen in the air, there isn't enough for you to breathe comfortably. It's less than 10% of today's oxygen levels. When Earth was first formed, there was only carbon dioxide, methane, and water vapor in the air. But more on that in a minute. As you step out, you look into the water surrounding you. It's completely still and there are no fish swimming in it, but it's filled with a ton of green, slimy stuff. What you're looking at is a whole lot of cyanobacteria, one of the most important bacteria ever to live on Earth. Cyanobacteria are responsible for the air we breathe, but they were also responsible for the most massive extinction event of all time. Flashback about 500 million years. To see how this extinction event happened, we need to skip back in time even further, another 500 million years. This time when you land, you'll definitely need your oxygen mask because there's zero oxygen in the air. The Earth will look a lot different from what you're used to, but there will be some familiar building blocks that are still on our planet today. It's wild to think that some things that have played a critical role in our history and will be so important for our future have been a part of our planet for billions of years. Take uranium, for example. Uranium is a naturally occurring element formed during the early stages of the universe, and it's been a part of our planet since the beginning. According to our resident experts at Uranium Royalty Corporation, just one pellet of refined uranium, about the size of your fingernail, packs about as much energy as 149 gallons of oil. That's some serious power. This kind of energy is more important than ever in today's world. We're facing an energy demand surge, just like in the 20th century, but in a much shorter time, thanks to artificial intelligence, electric vehicles, and even cryptocurrencies. If every car in the US went electric, we'd need 20 to 50% more electricity nationwide. And we can't just do it with renewable energy alone. Right now, renewables make up only 13% of US energy consumption. Solar panels don't work at night, and wind turbines only spin about 35% of the time. Meanwhile, nuclear plants, well, they're cranking out energy more than 90% of the time. Nuclear energy is a low-emission, high-capacity solution to our energy challenges, but it's often misunderstood and underestimated. Thankfully, our friends at Uranium Royalty Corporation are working to change that. They're the first and only publicly traded pure-play royalty business in the uranium sector. What does that mean? Well, it means they don't own or operate uranium mines. Instead, they invest in them and secure a percentage of what's produced. Their portfolio spans 19 royalties across key uranium-producing regions, including Cigar Lake, one of the largest and highest-grade uranium deposits on Earth. With the growing need for clean, reliable energy, Uranium Royalty Corporation is ready for the coming surge in demand. If you want to be part of the solution and maybe make a smart investment, well, click on the link in the description to learn more. Now, speaking of things that have existed for billions of years, let's talk about bacteria. Just like today, it was causing some big issues back then, too. Let's travel back to Earth about 2.5 billion years ago to see what I mean. Like the calm before the mass extinction event, everything looks great on Earth. Our young sun is a bit dimmer, even a little bit cooler, but temperatures on Earth are balmy, around 21 degrees Celsius. There's plenty of liquid water, but no ice. The carbon dioxide and methane in the atmosphere are driving a greenhouse effect. The only life that's around is in the water, and again, I'm not talking about fish. It's all single-celled organisms like bacteria, which were living in very different circumstances, like the zero oxygen environment you're standing in right now. But this water isn't only filled with boring bacteria, it's now filled with cyanobacteria. This bacteria evolved with a special trait, the ability to use water as a fuel to photosynthesize. And with this trait, it was able to produce oxygen. The cyanobacteria began to change the chemistry of Earth's atmosphere. As bigger and bigger colonies of cyanobacteria photosynthesized, they produced more and more oxygen. Now, this didn't result in much at the start, as much of the oxygen being produced would react with minerals and then get removed from the environment. But fast forward a few 100 million years, and things start to change drastically. Now, so much oxygen is being produced that it can't be removed fast enough. It oxygenates the water, it escapes into the air, it reacts with methane and displaces it from the atmosphere. Earth's atmosphere is filling up with oxygen and becoming breathable. But don't take off that mask just yet. The oxygen level is still only 20 to 40% of what it is today, maybe even lower, but this level is obviously much higher than the near zero level Earth had before. So, how do the other bacteria react to this new level of oxygen? Well, you can't see it happening because they're microscopic, but they're dying off in huge numbers. This is the Great Oxidation Event, also known as the biggest extinction event in Earth's history. The oxygen being created turned out to be pure poison for other bacteria, killing off 99% of all life on Earth. And this isn't the only catastrophic event happening. This massive amount of oxygen in the atmosphere is about to have a big impact on something else. The cyanobacteria is creating oxygen, but it's also wiping out two greenhouse gases, carbon dioxide and methane. These two gases played a key role in the evolution of Earth up until now. They help trap the sun's energy, keeping the planet warm. With both of these elements being removed and oxygen taking their place, it's starting to get very, very cold. Over hundreds of millions of years, you'd see massive changes in the landscape. The oceans are freezing. Sheets of ice are covering Earth. Brown and rocky land is now turning snow white. One of the earliest ice ages has begun. This is the start of the Huronian glaciation. It'll last about 200 million years. Throughout this time, you'll see Earth go through 3 glaciations. No part of the planet is spared. The continents, the poles, even at sea level. It's all ice all the time. Now, all life on Earth has already taken a severe beating, and these chilly conditions aren't doing much to help. Neither the oxygen nor the deep freeze are doing any good for the survival of our older microbes. But somehow, a small sliver of life, just around 1% of the living, persists over these 200 million years. No, sorry you can't see them, they're still microscopic and living in rare parts of the Earth. They're just hanging on, waiting for the ice to thaw. Wow, look at you, time traveling everywhere. You're quite the explorer. You know, if you want to explore even more, well, you should check out the What If Explorers Club on Patreon. There you'll find ad-free videos, get a chance to contribute story ideas like this one, and more. But our Explorers Club is in the present day, and right now, you're 2 billion years in the past, at a pretty significant turning point in history. A whole slew of exciting things are about to happen that will transform the face of Earth, both physically and biologically. Volcanoes are erupting, the ice is melting, a new continent is forming, and life is making a comeback. 3 different natural and geological processes started, beginning a transformation and ending the ice-covered Earth. Let's go through them. The sun is a little bit warmer now than when we flashed back the extra 500 million years, but maybe you noticed the sun is also looking a little bit brighter. Well, this is because the sun's luminosity increases at the rate of about 1 degree Celsius every 100 million years. So now the sun is 5 degrees warmer. But this warmer sun by itself is not what melted the ice sheets. A second natural phenomenon is now playing a role. It's typically known for causing mass destruction and extinctions, but at this point in history, it's shaping the continents and saving the Earth. I'm talking about volcanoes. Although Earth was just covered with significant amounts of ice, under the crust, it remains hot and molten. Plate tectonics are starting to change things deep below the surface. A giant surge of volcanic activity is happening. Powerful whirlpool currents of lava deep in the mantle can no longer be suppressed. Magma is swelling up under the Earth and breaking through in a series of volcanic eruptions. These explosive conditions will continue for another 300 million years. The small separate land masses that you saw as your time machine descended are being pulled together by this volcanic activity to form the first supercontinent, Nuna. Fast forward to today and you'd be standing in Colombia. The volcanoes are also causing a remarkable transformation of Earth's atmosphere. This will affect the climate, making it much warmer. Now, this change might seem catastrophic at first, but it's going to give life on Earth another chance. That's because these volcanic eruptions are spewing water vapor and carbon dioxide into the air, and there's no microbial life to remove the carbon dioxide yet, so more and more of it is accumulating, trapping heat and making Earth hotter. With this new heat, the ice sheets are melting away. This volcanic action is still affecting us today. The lava spewing from the volcanoes eventually helped turn carbon into diamonds. In fact, most natural diamonds today can be traced back to this era. So take a moment to think about this cataclysmic event 2 billion years ago on your wedding day. But this isn't all that's happening. Over in Africa, another massive event is occurring. Nature's first nuclear reactor. Now, you're probably wondering how you could possibly get a nuclear reactor going on Earth. After all, don't you need a concentration of radioactive material? Well, yes you do. And this is what that pocket of Earth had. During its formation, Earth had accumulated bits of uranium from interstellar dust. This uranium was created by supernovas as stars died and exploded. Over hundreds of millions of years, microbial activity concentrated this uranium, and tectonic activity had it buried deep inside of Earth. 2 billion years ago, the right set of circumstances came together. A nuclear fission reaction began in the concentrated uranium. Uranium is naturally radioactive, so it decays over time. It splits to release neutrons. Like one domino hitting another, these neutrons in turn hit other uranium atoms which split, and this causes a chain reaction, creating this natural nuclear reactor. This natural process might have important lessons for humans today. Burning fossil fuels is making climate change worse, and the pressure is on to explore other sources of energy, like nuclear fission. But one of the challenges has always been how to store nuclear waste safely. It's possible that by studying this uranium mine, we could learn something useful. All these processes are working to warm up the Earth. The warming sun, greenhouse gases from volcanoes, and in this particular spot, Earth's very own nuclear reactor. As temperatures rise, water is becoming more prevalent than ice, and the landmass of Nuna is shrinking. One more important thing is happening right now. You can't see a lot of it without a microscope, but the 1% of microorganisms that made it through the Ice Age are wiggling their toes. metaphorically speaking, and starting to thrive. New life evolved through the oxygen-rich ice age. Microorganisms evolved that took in oxygen to burn food and released carbon dioxide in the process. The carbon dioxide released was then used by the cyanobacteria to produce more oxygen. This was happening at a microscopic level. Today, it happens with all kinds of different creatures. Now, humans and animals breathe in oxygen and exhale carbon dioxide. Plants take in carbon dioxide, photosynthesize, and release oxygen. So, the cyanobacteria was one of the original building blocks for all life today. But the oxygen didn't just power up microbes. During the long ice age, it began to form a protective layer in the upper atmosphere of the Earth, the ozone layer. This protected new life from ultraviolet radiation. Practically speaking, it expanded the real estate of Earth. Microbial life could now live on thin films of water protected from radiation and use the sun's energy to photosynthesize. You know what? I just remembered I packed a special microscope in the time machine. I know, sorry, we could have used it earlier. But you can use it to take a better look now at how cellular life is evolving. At this point in history, cells are changing to become more complex, with a distinct nucleus. This will allow the first plants to borrow traits from the cyanobacteria, which allows them to photosynthesize. So we can thank these microorganisms for the creation of all plant life we have today. Without photosynthesis, plants just wouldn't exist. Other creatures began to form during this time too. Scientists have unearthed fossils of multicellular creatures. These are sea creatures with soft, gelatinous bodies. They come in many different sizes, some as long as 17 centimeters long. At the time, they probably burrowed into the mud of rivers. These particular creatures survived while oxygen concentrations were high, but later disappeared, leaving no direct descendants. Rest in peace, little guys. Their complex multicellular life is the basic blueprint for all multicellular life today. Plants, humans, animals, fungi. Even the algae from this time didn't disappear completely. They're preserved in beautiful rocks called stromatolites, and if you're ever in the mood to see 2 billion-year-old rocks, pay a visit to the Belcher Islands in Hudson Bay, Canada. Geological and biological events from 2 billion years ago are the key to life on Earth today. The oxygen we breathe, chlorophyll in the plants we eat, the beginnings of our complex multicellular existence, not to mention the protective ozone layer. Who knows? Maybe the past holds the key to our future. Maybe cyanobacteria could gobble up carbon dioxide and even save us from the climate crisis we're in today. As you head back to your modern-day Earth, it makes you wonder, what will life look like 1 billion years in the future? Well, let's check out one of my favorite episodes we've done exploring this scenario. If you traveled 10,000 years into the future, what would planet Earth look like? Would most of its surface be covered in volcanoes? Or would it be frozen in ice? What if you traveled even further, to 1 million years in the future? Would all of the oceans have evaporated? Or would it have become one giant water world? Okay, now, what about 1 billion years? Would there be any humans left? Or would they have settled in other parts of the galaxy? This is What If, and here's what would happen if you traveled 1 billion years into the future. Let's face it, the chances of any humans being around to greet you when you arrive 1 billion years into the future are pretty low. Several key existential threats face the human race, and if we want to be around in 1 billion years, we'll need to endure them all. We've seen how much we've struggled to come together just to survive a global pandemic. So, how do we have any chance of enduring the threats of climate change, overpopulation, global nuclear war, killer asteroids and comets, natural ice ages, and the sun getting a whole lot hotter? Well, let's take a look into the future and find out. Just under 10,000 years from now, we're going to run into a big problem called the Deca-millennium bug. In the year 10,000 AD, software encoding the AD calendar year won't encode dates with more than 4 decimals. Remember Y2K? Yeah, it's just like that, except hopefully we won't panic as much this time around. On the bright side, in 10,000 years, genetic differences and traits between humans will no longer be regional. Traits like skin and hair color will be evenly distributed around the world. Maybe that will help us all get along. Finally. 20,000 years into the future, none of the current languages will be recognizable. Future languages will only contain 1% of the core vocabulary words of their present-day counterparts. 50,000 years from now will mark a new glacial period for the Earth, which will start a new ice age. Niagara Falls will have eroded into Lake Erie completely. And, interestingly, a full day on Earth will also increase by 1 second at this point in time. So much more time for activities. In 250,000 years, the Loihi volcano will rise above the water to form a new island in Hawaii. And in 500,000 years, it's likely that an asteroid with a diameter greater than 1 kilometer will hit Earth, unless we can prevent it. The resulting crater will be no less than 400 kilometers across. It will start fires all over the planet and make the air unbreathable. So there's something to look forward to. And in case that's not enough, in 1 million years, we'll likely have another supervolcano eruption, large enough to spew out 3,200 cubic kilometers of ash. It would produce enough lava to fill 75% of the Grand Canyon. This would be similar to the Toba eruption that almost wiped out humanity 70,000 years ago. Oh, and the nearby star Betelgeuse will have exploded into a supernova by this time, making it visible from Earth even during the daytime. In 2 million AD, humanity will have settlements throughout the solar system. This also means that if populations on different planets have remained separate, humans may have evolved into other species adapted to their specific world. In 10 million years, a huge part of Eastern Africa will break off, forming a new ocean basin. In 50 million years, Africa will collide with Eurasia, closing off the Mediterranean Sea, and a new mountain range will form between the two land masses. This mountain range may include a mountain taller than Mount Everest. Out in space, Mars will collide with its moon, resulting in it developing a ring system like Saturn's. In 60 million years, the Canadian and American Rockies will have eroded entirely. In 80 million years, all Hawaiian Islands will be below the water. In 100 million years, an asteroid similar to the one that killed the dinosaurs 66 million years ago will likely hit Earth, one that is 10 kilometers wide. In 250 million years, all of Earth's continents will be fused together like Pangea, except this time it will be called Pangea Ultima. But don't get too attached to it, because in 400 to 500 million years, Pangea Ultima will separate again. In 500 to 600 million years, a gamma ray burst will likely occur within 6,500 light years from Earth. If it strikes Earth, it could damage the ozone layer and trigger a mass extinction. 600 million years from now, the Moon will be so far from Earth that total solar eclipses will no longer be possible. And the Sun's increasing luminosity will have raised temperatures on Earth so much that it could halt plate tectonics movement. In 800 million years, carbon dioxide levels will drop dramatically and photosynthesis will no longer be possible. Free oxygen and ozone will disappear from the atmosphere, and complex life on Earth will die. And finally, in 1 billion years, the Sun's luminosity will have increased by 10%, and the average temperature on Earth will be 47 degrees Celsius. Our atmosphere will feel like a damp greenhouse, and our oceans will evaporate, leaving just pockets of water at each of the poles. When you arrive here in your time machine, be mentally prepared to take in a planet Earth that looks nothing like the one you remember. The human race will be gone, hopefully living its best life on some other far-off planet. Because of the intense heat, lack of water, and lack of breathable air, Earth will be uninhabitable. So you probably shouldn't stay too long. Okay, with Earth in a less desirable position, let's jump even further ahead in time. A time where humanity has conquered the entire universe. Let's see what happens if we become a Type 7 civilization. In the future, humans may no longer have a need for physical forms. We'll be able to explore different multiverses and manipulate time itself. These are just a few of the perks of a Type 6 civilization. What would your day-to-day life be like? How far will technology have to advance? And would all this advancement really be worth it? This is What If, and here's what would happen if humanity became a Type 6 civilization. Okay, let's kickstart our climb up the ladder of civilization, otherwise known as the Kardashev scale. Named after the astrophysicist Nikolai Kardashev, this scale measures the advancement of a society based on its ability to harness different amounts of energy. Currently, today, we're a measly Type 0 civilization. And if we were to make the first leap on the scale up to a Type 1, we'd need to harness all the energy resources available to us on Earth. Going up to a Type 2, we'd extend our metaphorical extension cord all the way out to the sun. And that would mean much more than just collecting the solar power that reaches Earth. We'd be harnessing all the energy of the sun and the solar system. Now, at the third stage, Type 3, humanity would now have the ability to control all the energy available to us from the billions of stars and black holes in our galaxy. This might seem crazy enough, but we're just getting started. Once we become Type 4 and Type 5 civilizations, humanity would be able to control all the power available to us throughout the entire universe and beyond. And what comes next seems even more impossible to comprehend. Looking at what would happen if we became a Type 6 civilization requires you to fundamentally transform what you think you understand about the nature of reality. At this point, we wouldn't just be manipulating energy and matter, but also the fabric of space and time. And we wouldn't just be controlling multiple universes,
we would be able to create or destroy entire universes at will. You would have godlike powers at your fingertips. Time would no longer be something we'd think of as flowing in only one direction. Instead of looking at it like a river, it would now be a sea that we could jump in and explore freely. You could travel back in time to witness the birth of stars, the formation of the galaxies, and the very creation of the universe. And it would be as fast and simple as blinking your eyes. And if you could control time and create your own universes, then of course you could determine exactly what happens in them as well. So in your universal sandbox, there could be one world where you are the supreme leader, another with all kinds of animals that have never existed, and maybe one where money really does grow on trees. Not that money would mean anything to you. With this enormous and purely theoretical amount of power, what would it even mean to be human anymore? Well, first of all, you'd look pretty different. You wouldn't have much use for your body anymore, but with the technology of a Type 6 civilization, you could equip your body with all the most incredibly advanced artificial intelligence tools imaginable. But that's just the beginning. You might exist as pure energy and consciousness, without flesh and bone. You could take on whatever form you desire. You and every other human would truly be gods. However, being this advanced would bring up a handful of ethical dilemmas. For one, if you were omnipotent, you'd have to develop new social skills with all the other omnipotent beings of the universe. Keeping secrets would be pretty much impossible. And no doubt, as you navigated through multiple universes, you'd come across at least a couple of civilizations that would be much less advanced than ours. There would need to be some sort of protocol on how to engage with them in a humane way. Especially if you could create and destroy universes at will. This would be a great power that truly requires great responsibility. You'd be able to design new life forms from scratch and guide them through their evolution, just as our species once experienced. If you were to wipe those same species out in an instant, well, it would raise enormous moral questions. And there's probably one other burning question on your mind. If you were so powerful, what would be the purpose of your life? Well, that's one thing we'll just have to wait to find out when we reach this height on the civilization scale. And then there's always the next step, like becoming a Type 7 civilization. But that's a story for another What If.